Okay, so today we're going to look at graphs of exponential functions with any base. So what we're going to look at, so the base, meaning like in the question here where we see the a, we're saying that it can be any number. Oh, sorry. Okay, so what we're saying, if f of x equals a to the power of x, and we're saying that a can be any positive, so it's going to be above 1, or a positive number, a real number which is not 1, but above 1. So if you have a look, so that could be a, it could be 2 to the power of x or 3 to the power of x. So where we say where a is a real positive number, so we're saying a is an element or part of the set, but not 1. So that's just the way we can write it out in set notation there. Okay, so let's have a look at a graph. So for my example here, I've shown you 2 to the power of x is in the pink. So if you have a look, so 2 to the power of x goes, there's the pink line, and it comes up here like that. And if you look at 10 to the power of x, it has that same shape, but it squashes, or it goes closer in, so the dilation factor. Now you can see they both have an intercept of 0, 1. Okay, so here's the things that we can look at in the graph. So both graphs cross at the x-axis at this point, yes, because we know if you substitute x equals 1 into any of it, see like 10 to the power of 0, if you put x is 0, into it, you get anything to the power of 0 is 1. So 2 to the power of 0 is 1, 10 to the power, so it doesn't matter. So there's that. We can see it actually doesn't cross the x-axis at all, and so we have a horizontal asymptote. So it never touches this line here, it always just goes along, and that's the asymptote at the x-axis. And if you want to find another point, obviously if you put 10 to the power of 1, it's 10, and 2 to the power of 1 is 2. So we're just saying on all exponential graphs, if you put x is 1, you'll get whatever the base is. So we get 2 if we put 1 there. Okay, the maximal domain is the range, so the real field. So we can see if we go along here, so the maximum domain, so we can see it's taking on any x value, but the y, the range or the y values, it's only going along up here, so it's only positive real. They're both increasing, so they're both going up, and the greater value of a, so we saw a dilation there. We saw if it was 10, it was skinnier, steeper. Okay, so we've looked at a couple of things on the graph. Let's have a look. Now, if we have a negative number, so if we have a negative number up here, negative x, we see a reflection, because it's just the x negative, remember, we see a reflection in the y-axis. So you've seen our normal graph went like that, and so now we've got this mirror image in it. So yeah, so if you look at, now just remember, if I have a half to the power of x, we can say that's the same as saying 2 to the negative 1. So that would equal, you could say, 2 to the negative x. So it'll be the same. Okay, so let's look at a couple of features. It still has an asymptote of y equals 0, or the x-axis, so it never crosses there. And we can also see it has the y-intercept, and that's still the same, because anything to the power, it doesn't matter what, so a half to the power of 0 is going to give 1, because anything, so we still have this same y-intercept. Sometimes they'll refer to the asymptote, they'll say, if they were describing it, they said as x approaches infinity, so as we go along here, we get bigger and bigger. As x gets bigger and bigger, y, they'll say y approaches 0, so we can see it gets closer and closer, but it never touches. That's just like set notation for the asymptote. Okay, so we can see that we'll have this type of graph, the reflection of it. That's when the a value, so let's write this down, this is when a is a fraction. So it's anywhere between the whole number 1. So remember we said an exponential won't be equal 1, but anything in between there. So you can see you can have all fractions in there. So if you had a quarter fits in there, etc. Okay, so now we're going to look at some transformations of our basic exponential graph. So here in this example, if I've written the basic one, so we see f of x equals 2 of x. So here we go, and you can see it's in the orange there. So we've got a y-intercept of 0 and 1, and it's asymptoting on the x-axis. So that's the basic graph. So there in the brown though, we can see we have we've got 2 of x plus 3. So this moves the graph. So this moves the graph up 3. So if you do up 3, so you can see, so that means you move your asymptote. So if the asymptote was on y equals 0, the asymptote is now on 1, 2, is now asymptoting on y equals 3. Okay, and if you can see the new y-intercept for this one, so the y-intercept's when x equals 0. So if you pop that into your formula, you have y would equal 2 to the power of 0 plus 3. Anything to the power of 0 is 1. So you get 4. So you can see how you get the y-intercept is 0 and 4 as well. So that's a vertical transformation. So we're moving up. Obviously, if you have a minus, you move it down. Okay, now we're going to have a look down here at the next one. Okay, so the basic one that I've drawn is a 3 to the power of x. So that's C. So you can see the asymptote for this one is still at y equals 0, or the x-intercept, and the x-axis, and the intercept, the y-intercept, is still 0, 1. Okay, so then if you look at the new graph, let's see what's happened when I times it by 2. So I've times it by 2 and I've added 1. So the 1 moves the asymptote up. So we've now got the asymptote at y equals 1. Okay, so, and you can see there. And if we look at the y-intercept, that would be when x equals 0. So we would get 2 times 3 to the power of 0 plus 1. So we get 2 times 1 plus 1, so we get, 3. So y equals 3. So the intercept is 0 and 3 for this one. So that's how that number has come about. And you're asymptoting on the here. If you have a look at y equals 1. Alright, and the last example, let's have a look. Okay, so with this last example, I've done a basic one, but I've done -3 to the power of x. So this is an exponential. So if you have a look, just talking about our transformation, see we've made the whole function negative. So we've sort of made the y. So when you see that, it's a reflection in the x-axis. And so if you have a look, so I'll go back. So, we normally see our exponential look like that. So can you see... So you can see we've reflected in here. So it's like you put a mirror there and you get, so this turns down. So you get your graph to go down the other way. All right, so we've seen that, that's what that's done. But if I look at what happens if I then have a little bit of movement as well. So this plus 2, this moves the asymptote up 2, yeah? Asymptote up 2. So you can see 1, 2, why it's asymptoting along y equals 2. So it's just moved it up. Okay.